Hi! Quite often in organic synthesis, we need to heat our reaction. Heating will provide the reactants with the necessary activation energy, and it will also speed the rate of the reaction. As shown here, Arrhenius equation tells us that the rate of the reaction should increase if we raise the temperature. This explains why heating our reactions can sometimes save us a lot of time. Some reactions require activation energy, as shown here. We supply this energy in the form of heat.
But how much heat is required?
Here we see the Boltzmann distribution for different temperatures. The marked area under the curve represents the number of molecules that have enough energy to undergo the reaction. It is exponentially larger at higher temperatures. The problem is that if we heat the reaction for too long, a big portion of the solvent might evaporate, which will make it difficult for the reaction to proceed. If, however, we connect a working condenser to the flask, all the solvent molecules that evaporate will climb up the condenser until they're cooled down. The evaporated solvent will then condense back into liquid and flow back to the flask. This sort of setup is called reflux. Refluxing allows us to keep a reaction at the solvent's boiling point for hours and even days without having to refill the solvent levels. When plugging in the hot plate or heating mantle, make sure the wiring does not touch the hot parts. Melting the wire could cause a short circuit or even start a fire. The stability of your setup mostly depends on the first clamp. Make sure it's well tighted and fairly leveled. Tilt in the flask before inserting the magnet can reduce the risk of breaking the glass. Connect the water tube to the bottom of the condenser and the draining tube to the top. In some cases, you might want to grease the condenser. Doing so can prevent gases from escaping the flask and moisture from entering it. Grease can also prevent alkaline reactions from causing the joint to stick together. Try to use as little grease as possible. Connecting the condenser to a clamp may increase the stability, but is not always necessary. Start the stirrer and turn on the heating. Congratulations, you are now refluxing. In case the reaction is sensitive to atmospheric moisture, placing a drying tube at the top is recommended. Now that the solvent is boiling, you can see the height of the reflux ring to decide if your condenser is long enough.
After disconnecting the first tube from the condenser, place your thumb on the opening. This will prevent water from coming out the other side. When you're ready, simply empty the condenser into the sink or to the nearest glassware.
Good luck in the lab and have a pleasant reflux.